Hi and a very good morning to our lecturer, Dr. Rizwan Effendi. Before I start, I will introduce myself first. My name is Ilham Yaakob Belemza, metric number D202020973130. Today, I will present topic trigonometric substitution, which is the subtopic from integration. From this topic, we are often integrating a function involving a radical by picking a clever substitution. You can often remove the radical and make the problem into a trigonometric integral and process from there. With that said, many of these problems have many steps and require you to know derivative formula and more. Many of these problems test your algebra and trigonometric skills as much as your calculus skills. In this topic, we will be solving definite and indefinite integral by using trigonometric substitution. First, I will talk about the introduction. With the trigonometric substitution method, you can do integral containing radicals of the following forms, which is sec u square plus a square, sec a square minus u square, and sec u square minus a square, as well as powers of those roots, where a is a constant and u is an expression containing x. For instance, sec a square minus u square. There are some tricks to help you keep the three cases of this method straight. First, the three cases involve three trigonometric functions, which is tangent, sine, and secant. Their initial letter T, S, and S are the same letter as the initial letter of the name of this technique, trigonometric substitution. Table 1 will show how these trigonometric functions pair up with the radical forms. In the next table, I will show you 6 types of substitution that we can use to solve this problem. You need to remember this formula to make you easy to solve this topic. In this trigonometric substitution, there are 3 types of cases we must solve. The first one is tangent, second one is sine, and the last one is secant. As you can see in the slide, I will explain cases 1 and case 2 only. For the case 3, I will skip because all the steps are basically same as in cases 1 and 2. For the case 1, tangent, the first step you must draw a right triangle where tangent theta equals u over a, which is 3x over 2. Because you know that tangent theta is equal opposite divided by adjacent. The triangle should have 3s as opposite, the side opposite, the angle theta, and 2 as adjacent, the adjacent side. Then by the Pythagoras theorem, the length of the hypotenuse automatically equals your radical, which is sec 3x squared plus 2 squared. Or we can write as sec 9x squared plus 4. You can see at the figure beside that. For the second step, solve tangent theta equal to 3x over 2 for x, differentiate and solve for dx. As you can see, I already solved the problem below here. The third step, you must find which trigonometric function is represented by the radical over the adjacent and solve for the radical. For the fourth step, use the result from step 2 and 3 to make substitution in the original problem. Then integrate it. And then for the fifth step, you just substitute the x expression from steps 1 and 3 back in for secant theta and tangent theta. You can also get the expression from the triangle in figure. For the cases 2, sines, the first step you must draw a right triangle with sine theta which x over 4. Sine equal opposite divided by hypotenuse. So the opposite side is x and the hypotenuse is 4. The length of the adjacent side is then automatically equal to your radical, sec 16 minus x squared, as you can see in the figure 4. For the second step, you must solve sine theta equal to x over 4 for x, differentiate and solve for the dx, as you see how I solve the problem below this. For the third step, you must find which trigonometric function equal the radical over the a and then solve for the radical. The fourth step is you must use the result from step 2 and 3 to make substitution in the original problem. Then integrate. You can see as I've written down here. The fifth step is the triangle show that cos theta equal to sec 16 minus x squared divided by x. Substitute back for your final answer. And then you will get the answer. The answer is negative sec 16 minus x squared divided by 16x plus c. Okay, that's all from me. Thank you.